Well, welcome back to our third part. I actually was almost done with the third part, and my video recording software decided to not be very friendly and it crashed on me. So I'm redoing this thing. Hopefully, I will do a better job than I did in the last one. So, right now, again, we're talking about wireless security, wireless networking, and a whole bunch of other stuff. So, the first thing we want to do is learn how to secure an enterprise wireless network as well as a personal wireless network or a small business wireless network. So, we're talking about open authentication, and that's nothing more than allowing any MacBook, any laptop, any iPhone, any tablet that has a MAC address, which is really nothing more than your wireless controller over here or your wireless network card. And the wireless controller or the access point, depending upon how you're actually connecting, it's just looking for a MAC address. You have a MAC address, okay, you can now authenticate on the network. What you're going to use is a shared key authentication. The open allows you to connect as long as you have the credentials. With the shared key, the credentials are going to be a password. And sometimes they call it a passphrase. 802.1x is a little bit more sophisticated. That involves a username and a password and a radius server that you're going to use basically in the high level and business environments that need a very, very secure environment. Then we also have what's called a root access point, where you can put in a little access point that usually has DCHP built in or something to that effect, and a user will actually authenticate to that. Everything will go through there. So all the information is now accessible to the hacker. We have data emanation, and that's really nothing more than an electromagnetic field generated by a network cable or a network device, such as a wireless router, and that can be manipulated, unfortunately, to eavesdrop on conversations, which of course is used to steal data. Then we have packet sniffing, which is basically the same thing as eavesdropping, and that's the interception and decoding of wireless transmissions, which is why it's so important that you decrypt and encrypt all the important information. So the decrypting is done by your end, and the encrypting is done before it goes out on the wire itself. So wireless transmissions, unfortunately, are easy intercepted, which is why it's crucial to encrypt all of your data before it gets transmitted. Interference is just like what it says, is something that can corrupt or degrade or even destroy the wireless signal. Then we have jamming, and that's a signal interference that's created intentionally by an attacker to make the wireless network impossible to use. And we have a deauthentication attack, and basically what happens there is you're going to use a spoof of MAC address, and then it's going to have your wireless controller is going to disconnect you. It's going to say disconnect you from the network, and then all of a sudden you get disconnected. So what are you going to do? You're going to try to connect, and this time you're going to connect to an evil twin or a man in the middle in there. So Bluetooth, we all know about Bluetooth. You go to the gym, everybody's got Bluetooth headphones. You can tell they're Bluetooth because you see no wire. When you use a keyboard or mouse that has no wire, of course, they're all wireless. Then we have a PAN, which is nothing more than a personal area network, and that is a bunch of connections that are connected to one type of controller. So we're talking about security. Two things: authentication and encryption. Authentication is really nothing more than saying you're who you say you are, sort of like showing a driver's license. But that doesn't give you the right to access information because we know that you are who you are. Using the encryption prevents people that are not supposed to have access from having access. So here we have the open system authentication. It uses the MAC address to authenticate, doesn't require the client to provide any more information other than that. So you can send information, receive information. However, we don't recommend that. What you want to do here, we have 802X, and that's strictly very, very, very safe and secure. But of course, you know, things happen all the time. How you have it here, you notice you have a username and a password. You can use a certificate, a digital certificate, which are rather stringent to get. You have a radius server, and that's going to require a username and a password in there. Okay, now we have, again, the authentication, the encryption in here. So to protect unencrypted channels, you need to encrypt all of the signals on the network. So it protects it by encoding wireless communication before they're actually transmitted. So then we have the third type is a shared key authentication, which most of the time you're very familiar. That uses a four-way handshake, sort of what we learned before. And then what you're going to do is type in the username, rather just the password, and that should allow you to connect in here. So we have WPA, which stands for Wi-Fi Protected Access, and it uses TKIP, which is Temporal Key Integrity Protocol. That uses rotating keys. The problem with that is just not as secure as it should be. It's using the RC4 or reverse cipher 4, and that is going to use encrypt in case the data packets before they're transferred. But again, as I mentioned just before, it is not the most secure. It can be cracked for people that have a little bit of patience. So normally what you want is WPA2. Sometimes it's called WPA2 Personal, WPA2 PSK for pre-shared key, and that provides much better security. It gives you the option to use AES with CCMP, which is most secure of all. You can use AES with TKIP, but it's not recommended because CCMP is much higher level of security. So here's what you're going to do. So now you go to Best Buy or Office Depot and you've got yourself a little home router. The very first thing you should do is change the administrator password. Most of the time it comes with admin and there's either no password or it's just plain password, which means anybody can get into it and can do whatever they want. So if you change the username and password, I recommend that you don't use admin as the password. Use Billy. Who's going to guess Billy as that? Or something similar that nobody's actually going to guess. Then you want to change the SSID from what it comes to default. Usually it's just going to be the name of the device, the manufacturer, and some kind of random number. Change it to something that is not identifiable. And I recommend, if possible, that you don't broadcast the SSID. You should know what it is, and then you can actually create your own profile. The only issue is, of course, if somebody comes to your house that you want to be able to give them, then you need a little bit of extra step. But if they can't see what the SSID is, people going by are not going to be able to try to authenticate to it. MAC filtering allows you to say, okay, the following MAC addresses and only these are allowed to authenticate. While that sounds like it's really secure, the problem is people can find out what your MAC address is. It's not really that difficult, and they can spoof it, so that'll allow them to do it. So it's not a foolproof method in here. And then you also want to periodically update the firmware. That should tell you an update's available, sort of like when you have Windows 10, every day new updates are available because they find issues with the software, and they'll close patches, they'll close holes, security things, and update databases and things of that. Then you want to enable your firewall. Most of them all come with a firewall, so you can block certain IP addresses. You can block people from getting in as well. So here we have the wireless security, and we talk about wireless attacks. An evil twin, notice the evil twin is nothing more than a second controller. So it sets it up with the same SSID, so you really don't know what. So now you're in an airport, and you're connecting to the airport SSID. Well, that's really fine. It's not a big deal. at that point in time. But however, you can jam the signal, which causes the person to disconnect, and then they reconnect. They're going to reconnect to yours because you're going to have a stronger signal. Or you have somebody that's just sitting close by with you, and he's going to connect automatically. But one thing to note is you do not actually have to have a wireless access point. It's kind of obvious if somebody has that. It can be set up as a notebook, so it just looks like somebody surfing the web on their notebook when they're actually taking control over different devices and using packet sniffing to capture all of your communications. And if they get caught, they just close the app real quickly and nobody can really tell what it is. So what they want to do is they want to snap, they want to pilch, and they want to set up a man in the middle. The man in the middle is very, very dangerous as well, because often what happens is they think that they're actually connected to their bank, but they're really not. So be very, very careful. So also you have to be careful of filtering when you're looking to a site that looks just like your page. I would never, ever, ever, ever put my username and password in any network other than my own home network or my office network, which I secure myself. Going to Starbucks, going anywhere, there's no security in there whatsoever. Yes, it's encrypted, but anybody can find a way to crack into it. So be very, 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 very careful about that. So we have war driving here. So war driving is somebody goes around and is looking for open networks. And what they're going to do is they're going to mark it on a map and then they're going to drive away. So it's not like you're going and doing anything. War chalking is the same, only they're actually going to mark it in a building or somewhere. So you can see symbols that they use for open and closed, and then they put the SSID so other people can find it. Package sniffing. So here you have a wired network. You configure the network card to operate what's called promiscuous mode so that it can accept all packets coming across the wire, not just the ones that are addressed to it. So this gives you information about the data being transferred on the network so you can possibly get usernames, passwords, or other sensitive data. Then we have snorting and snarling. So sniffing electrical signals on the wire, the attacker actually captures radio signals that are broadcast by the wireless devices. And to do it, it just simply puts a network and adapter system to set into monitor mode. That's all it is. So now we have air snort, attack NG, and wire snack are just packet sniffing tools. Wireshark is used a lot in businesses. I use it to see what's going on inside of my network. We have troubleshooting here now. We want to optimize a wireless network. We want to explore network problems, and we want to troubleshoot some network problems. First thing is a directional antenna. Then you have the omnidirectional antenna, the different types. One goes in a straight line, one broadcast, so it does it in a 360-degree pattern. And then we have a bandwidth station. So bandwidth saturation is the point where all of the available bandwidth on an internet connection is achieved maximal capacity, and you can't pass any more data through the connection. And then you have device saturation, where the actual percentage of CPU time, the IO request or requested device, is going to be 100%. Frequency mismatch is one's on one frequency and one is on another one. And then you have absorption, is when a signal passes through the objects, they lose power or get weaker, such as a wall. Refraction is again when the radio waves pass through objects at different densities, and then you can see that the signal can bend or possibly change speeds in there. So we have some issues here. Wrong SSID if people are trying to connect, especially if it's not broadcast and they have the wrong SSID. Then you have the security type. Maybe somebody's trying to connect with one security and really the other one is the one that's there. Now, however, that should be auto when you go in with your iPad and you see that you need to connect. It should tell you. However, if you're creating your own profile, it will ask you which type of security. Wrong passphrase. You know, obviously, same thing if you're trying to log into some kind of account and you're using the wrong password, it's not going to let you in, or the wrong 802.11 standard in here. So those are issues where you might have one laptop that can only use the older technology, such as B or G, and you're broadcasting in N. These are the speeds that can broadcast. So you can see B is only 11, and G and N are much, much, much higher. So we have basic trouble distance is one of the biggest ones. So the farther apart you are, the weaker the radio signal. Just think that when you're standing next to somebody and you're talking, they hear you just fine, but if they're 20 feet down the road, they may not hear you as well. Here we have motion. The person is walking. The faster they walk, the more possibility of data corruption or not being able to hear because the signal gets weak. Then you have passing through an object. So you can see as it goes through the object, it's very, very, very wide, and now it's thin, so you might not be able to get the same throughput. Then we have radio waves go through objects. They lose their power. That's called absorption. So some materials can cause more absorption than others. Metal and water are really perfect examples because they can't pass through them. So now we have over here some more. When your radio frequency passes through objects at different densities, you can see how the object can bend in there. And of course, change speeds. That's called refraction. And again, signal loss. So we have EMI, electromagnetic interference. We have frequency ranges. I can see I decided to play with some animation in here. We have weather as an issue. We have latency as an issue. We have RNI interference, your antenna type, and antenna and access point placement. All of these can affect your wireless. Then here are your specifications for B and G, for A and AC, and for N. Troubleshooting here again, we could be using half duplex when we should be using full duplex. So you can see how that can affect everything. Antenna types, again, a review, directional versus omnidirectional. And then we have a building here. The WAP is in the basement, going through a concrete wall, which is usually, the concrete usually wins. So be very careful with that. So it's very strong in the first floor, but then it gets very weak as it goes to the second floor. And you can see basically all the floors here are useless. Very, 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 very. So you might have to wire them. Here's an omnidirectional, and we have, see, it goes over here. It's going to straight. Here is the straight one, and the omni is going all through over here. So in order to do it, you have straight ones in combination with an omni to allow for the dead spots. And then we talked about that. So that is the end of it. I hope this was helpful. Hope that you have a great, great day. Remember, all of this is available in the videos. This is just a brief summary, and it's not designed to be a self-exhausting lecture in here. So hopefully this, with conjunction of your videos, and you'll grasp the thing. As always, remember, if you have any problems, please email me, and I'll do my best to answer any questions. So have a wonderful, wonderful, wonderful day.